All right, welcome back to Computer Vision. Today we're going to continue, well actually we just introduced tracking and now we're actually going to do some. So remember last time we talked about the difference between detecting and tracking. Detecting, we have some operator and we just find whatever our target is in every frame. In tracking, we're going to predict the new location of an object or the expected distribution location of an object using estimated dynamics. So somehow we're estimating the velocity, accelerations, whatever. And then we're going to update based upon the measurements that we take. So that's sort of the, shall we say, the intuitive way of describing it. What we're going to do this lesson, the next lesson, the lesson after that, I don't know, probably for the next 8 or 7, 12 years or so. What we're going to do is we're going to make this much more formal. And basically, tracking as a form of inference. And what we mean by that is we're going to have some state of the object, some state we're trying to estimate. We're going to call that x. That's the parameters we care about. But we don't actually know that. So we refer to that as being hidden. And we have a sensor. Typically, it's going to be a camera for the stuff we're talking about. And what it's doing is it's taking some measurements. It's measuring like our raw detections that we were doing before. And we're going to refer to those as noisy observations of whatever the underlying state actually was. The system that we're assuming is that at every time step t, the state, the underlying state changes from x of t minus 1 to x of t. So here we have x of t minus 1 to x of t. And then at time t, we get a new observation. We get a new measurement. And our goal, your mission, should you choose to accept it, is to recover the most likely state time t. Now, I was thinking about that. It's actually, that's not quite right. What you want to do is you really want to estimate, not the most likely state, I'm going to cross that out and say the distribution or density. So if I have the density, that is I have some belief about where x might be, I can tell you the most likely place, that would be the highest probability. I can tell you the average guess, that would be the expected value. But the idea is that we're going to have a density. And so your goal is to recover or estimate this distribution given, first of all, everything you've seen so far, right? So you've been taking measurements all along since last Tuesday. Where is this thing now? And the other thing that was given to you was some knowledge or some model of the state dynamics. That is how this thing moves. Now, you may have to estimate some of the parameters, but you may know that, I'm going to assume that this thing has a particular velocity and the acceleration is just some noise. That would be a model that you're going to assume is known.